Today we're going to talk about dilations. A dilation is a transformation that moves the points of a figure either toward or away from a point called the center of dilation. The center of our dilation is usually going to be at the origin, which is 0, 0. Scale factor. The new ratio of a new image to its original image is the ratio of the corresponding sides. When a scale factor is greater than 1, the shape gets bigger, which is also called an enlargement. An example of scale factors would be k equals 2, k equals 3/2, k equals 5. When a scale factor is less than 1 but greater than 0, the shape gets smaller, which is also called a reduction. So examples for scale factors would be 1/2, 1/4, 1/3. However, it would not be k equals -2 because it said that it has to be greater than 0 and negatives are not going to be allowed for scale factors. To find your scale factor of an image, you must find your ratio by taking and matching the corresponding sides of your figure to the other corresponding sides. The ratio would be consisted of the new image on the top of the fraction, and then the original image will be on the bottom. So our first example, we're going to find our scale factor of the two squares. As you see here, A is the pre-image, and then the A prime is the image. And then we could also say the pre-image is the original image. So that ratio on the last slide said our ratio is going to be the new image, which is the prime, over your original image. So looking at our ratios, the new image, again, would be your A prime, so it would be 6 over your original, which is 2, so our scale factor is 3. 3 represents an enlargement because we went from A to A prime, so obviously we see an enlargement of the shapes. So in this next example, we're finding the scale factor of the two triangles. Remember that our ratio will be where the new image is going to be up top over the original image. And so our new would be A prime, which is 3 over our original, which is 6. So our sides are corresponding to one another, and that reduces to 1/2. So 1/2 represents a scale factor. That is a reduction. You can see from A to A prime that the triangles got smaller. And so remember, reduction means a value less than 1, which 1/2 is less than 1, but also greater than 0. This next example, we're going to find the coordinates of the dilation image for the given scale factor k. So we're given 3 different coordinates, and our scale factor is 2. Now we talked about what 2 would be. 2 represents an enlargement. So our new points should have bigger numbers because we are enlarging these 3 points. Now to write our new points, we'll say G prime, because remember prime represents new. So we have to multiply 2 times every value times each x and y in every coordinate. So 0 times 2 is 0. -2 times 2 is -4. So then we go to h prime. So then we do 1 times 2, which is 2. 3 times 2, which is 6. And one more order pair. So I prime. 2 times 4, which is 8. 2 times 1, which is 2. So these 3, G prime and H prime, are the new order pairs for these coordinates. So this last example, we're still going to be finding the coordinates of the dilation image for the given scale factor. This time our scale factor is 1/4. Now 1/4 represents a reduction. So when you're doing this, you have to take each individual x and y and multiply by 1/4. So for the first one, we have L prime. So we have 8 times 1/4, negative 8 times 1/4. Okay, so that right there will reduce to 2. And the next one will reduce to negative 2. Same thing for the next one. N. 0 times 1/4. 16 times 1/4. Well, 0 times anything is 0, so that first one will be 0. 16 times 1/4 will be 4. And then our last one, M prime, will be 1/4 times 4. And then 5 times 1/4. So M prime will equal 4 times 1/4, which is 1. 5 times 1/4 will be 5/4. So, I wrote out every little step for this particular one because I don't want you guys to get confused with the fraction here. You could say just you're dividing, or you could say you're multiplying, but do not forget that we are multiplying the scale factors for each individual x and y for all the coordinates.